All right, we're going to finish up 2-3 today. Oh, let's start over. There we go. It is working better now. 2-3.
I bought 4 styluses.
See, you did?
To figure out which one was working.
Oh. All right, we're going to do the intermediate value theorem. The intermediate value theorem. Thank you, Kevin. The voice of reason. Okay, we're going to do something called Theorem 8 today. Some books are funny like that. They'll label the theorems as you go along. So we did Theorem 6, which was if it's continuous and it's the product, sum, quotient, any of those things, then it's going to be a continuous function. Theorem 7 was composition of functions are continuous if their original functions are continuous. And then this is Theorem 8. Theorem 8, the intermediate value theorem for continuous functions, says this. Y equals f of x. Y equals f of x that is continuous on AB. That is continuous on the closed interval from A to B. Okay, maybe it's not continuous over its entire domain, but in a closed interval from A to B, what happens is, and this is going to be like kind of a duh thing to you, so it's continuous from A to B, then that means that it takes on every value between f of A and f of B.
Between and including?
That's a good question. I think so. Yeah, it has to, because A and B. Yep. Every value between f of A and f of B. So then they draw this little picture in the book to kind of show you what's going on. So let's say that this is A and this is B. And then we'll have a point here that is f of A, and f of A exists. And then let's say that we have a point up here, f of B also exists. Then that means that you can draw, it's going to take on every value between f of A and f of B on the range. And so they do something that looks like this, like that. So it's all continuous. There's no breaks in your graph. And so if you picked a point, for example, like let's pick C, then there will be a value f of C. That's not between f of A and f of B here, though. It's weird. It says this happens because f is continuous, and this could fail if f is discontinuous at one point.
Yeah, isn't the graph would go above f of B?
Wait, should it
Right.
Should it be f of A
No,
on the
but they
bottom?
draw it that way, though.
But should A and B be on the side and f of A and B be on the bottom then?
You know what they did was they picked a value C over here, but if that value's there, it should work too. And they picked that.
If we switch
They say that's Y0.
the labels, then it would make sense.
Right, I know, but why? Maybe that's like a special case that no matter what you pick here on the graph, it will end up in here. This one just so happens to be outside of it, because that can happen too. So all of these are going to work. I happen to pick one that was on the outside, which also works too. But these for sure, that's what the theorem is saying. All of those for sure will work. I just so happen to pick a different one. Neat. Okay? All right, then they give you this one example. Here it is. Example. They ask you this weird question. They say, is any real number exactly one less than its cube? Exactly one less than its cube. Okay, and then it says, if so, compute this to 3 decimal places. So there is going to be a number. Is any real number exactly one less than its cube? So let's say that x is this so-called number. Okay? We want to find if this is equal to what? X cubed minus 1. Perfect. Okay? And what I would do is to solve this, which is not easy to solve algebraically, I would graph it. I'd bring the x over, and I would have x cubed minus x minus 1 equals 0. And so you can go ahead and go to your calculator. I would graph this as y1. I would graph that as y2. And then what happens is you get this graph right here. I'll show you. Yeah, you can graph it if you want to. But it just goes like this and like that. So there's our cubic function. And then, so that would be y1. I'll draw it in blue. Here's our cubic function. It's y1. And then y2 would be the line through there. And then we want to find this point right here. There's only one real number that's going to be 1 less than its cube. And so you calculate that. Did anyone do it? Ooh, nice. 1.324. Approximately. 1.324. Okay, it says that the function changes signs between 1 and 2, so there must be a point in between there that's going to work, and that was that point between 1 and 2. And that has to do with the intermediate value theorem, that between 1 and 2, it's going to be continuous in there, and so it happens to be the point in there somewhere. Okay, and that was it.